All right, if I ask you, find the limit as x approaches 2 from the right of s cubed minus 6x squared plus 8x over the square root of x minus 2. All right, so if you could factor everything, it would be a lot easier to do. Notice again, if I put 2 in place of x, obviously the denominator gets 0, right? So we have any little issues. But in fact, I'm not actually putting 2 in there, right? We're approaching 2 from the right side. So I'm looking at numbers like 2.00001, a little bit bigger than 2, right? And so you still might be able to get an idea that what is that going to, but factoring is going to help this out a lot better. So rewrite this as the limit as x approaches 2 from the right. And we're going to factor the numerator. Notice there's an x that can come out, right? So that leaves x times x squared minus 6x plus 8, and that can factor. All right, so this is right here, x squared minus 6x plus 8. That trinomial factors this x minus 2 times x minus 4, correct? And then the denominator, I'm going to rewrite this. This is a big hint that you use a lot in calculus. Square roots can always be rewritten as something else, as factors, as powers, I'm sorry. As the radicand, x minus 2. If I have a square root, what is the power? It's 1/2 power, right? So I can rewrite it like that. Now you can see that you have the same base down here. Like base is being divided, what's the rule, if you remember? Keep the base and subtract the exponent. Numerator is a 1 minus denominator is 1/2. So that's x minus 2 all to the 1/2 left over in the numerator. All right, so now I can put a 2 in there and see what happens. If I put a 2 in there, I get 2 right there. 2 minus 2 also the 1/2, that's 0, right? And then I can put a 2 right there, 2 minus 4. So this is 0 right here. Anything multiplied to 0 makes the whole product 0. So there's your limit right there. So the same process, whether you're going from left or to the right, but now we're just looking specifically at one side. The denominator cancels out, we can evaluate straight into that polynomial format. Yes?
So when you have the x minus 2 to the 1/2 power, how did you cancel out the other?
If I have something like this, x to the 5th over x squared, isn't this to keep the base of x? Numerator exponent minus denominators. And that gives you x cubed, so that's what I did here. There's my numerator minus denominators. And just simplified to that. You can almost think of about it. How many more x minus 2s than you have in the numerator than the denominator? Half of them, if you might think of it in that sense, right? That's factors. Let's see. I used to teach a business calculus class, and they actually had a lot more examples that were more algebraic techniques, I would say, than they actually have in here. I should say you have something like this. Find the limit as x approaches to I'm just making up numbers. Again, here you can just plug in, right? That's your first attempt. It's just to plug it in and see what comes out. Now you may or may not be familiar, or haven't seen in a while, negative exponents, but a negative exponent can be rewritten as positive exponents easily if you wanted to. All you have to do is this is a single monomial term right here, right? X to the fifth in the denominator. So I could rewrite this as a much simpler expression as the x to the negative 3 over the x to the fifth plus the 7x to the negative 4 over x to the fifth minus the 5x to the negative 2 over x to the fifth, and then simplify each one of these individual fractions. Makes it a little bit easier. Now remember, a negative exponent just means that the base of that exponent will move and become a positive exponent wherever it moves to, right? So this is in the numerator. It's going to go down to the denominator and become x cubed. So now we have this first term will be 1 over x to the eighth. Could have picked some nicer numbers if I wasn't making it up off the top of my head. But same thing with this x to the negative 4 is going to go down and become x to the positive 4 times x to the fifth down there will be x to the ninth. And then this will be minus 5 over x to the seventh, right? Now they're all positive exponents, we could work with these numbers. And this is just going to be 1 over 2 to the eighth plus 7 over 2 to the ninth minus 5 over 2 to the seventh. And from here, you can use a calculator and figure out what that number perhaps would be. I'll type it in real quick, see what we get. It may just be a rounded decimal. 1 divided by 2 to the eighth plus 7 divided by 2 to the ninth minus 5 divided by 2 to the seventh. And let's see if we change it to a fraction to get an exact value if it works. There it is, negative 11 over 512. There's your answer. And you still could have evaluated it at the very beginning, doing the same thing with the calculator. I was kind of hoping we wouldn't need a calculator, but that was some ugly numbers to work with. So just a few techniques right there. If you have negative exponents, if I would have perhaps some radicals involved, we did some like that. Like this one. So again, try to put in 0 in there. You can see 0 is the denominator, makes the function undefined. We can't do that. We're approaching 0, right? And I'm not saying specifically for one side, so it's understood to be from both sides, right? So if I can rearrange this to where I can not have an h in the denominator, I might be able to evaluate 0 into it. So complex fractions, one way to clear out a complex fraction is look at all the denominators and find an LCD. So 5 plus h would be a factor. 5 is a factor. Now you might say, well, 5 is right here, but inside the parentheses, 5 is not a factor. 5 is a term, right? It's being added. I need multiplication, so I need 5 being multiplied. And then I go over here, denominator on the h right there is a 1. Think of all of them as individual fractions, right? So there's my LCD right there. I will multiply this LCD to every term in here. So I'm going to have 5 times 5 plus h, 5 times 5 plus h, 5 times 5 plus h. And you're going to see all the fractions will cancel out. Their denominators, that is. 5 plus h goes away here, here. 5 goes away here and here. And now we're left with still the limit as h goes to 0 of now 5 minus the 5 plus h in parentheses over 5h times 5 plus h. Simplify the numerator. Distribute across, you would have 5 minus h over 5h times 5 plus h. 5 minus 5 goes away. An h in the numerator cancels with an h as a factor in the denominator. That's what we want it to go. We want that h factor to disappear down there. So we got -1 on the top, 5 times 5 plus h on the bottom. Now can you put 0 there? Yes. -1 over 5 times 5 plus 0 is 5 times 5 is 25, -1 over 25. There's your limit. So you see, there's really not a whole lot of real calculus applications. This is really just algebraic. Right? All we're doing is just rewriting something that's already given using some algebraic techniques, multiplying top and bottom by some numbers, perhaps, simplifying, factoring. Throw in a little bit of trig. So the first thing you'd say, okay, let me see if I can put in 0. Sine of 0. I don't remember it. Well, just use your calculator if you can't remember that. But sine of 0, 0 degrees or 0 radians either, is also 0. That's 0 in the denominator of that expression. Can't do that, right? So you can't just evaluate right away. So we need to rewrite this some kind of way to where hopefully sine x disappears in the denominator, right? Sine 2x, that's a big hint right there. How long ago was trig? Pre-calculus, maybe last semester, and this is at the beginning of pre-calculus too. There's just kind of a reminder, some trick stuff that you've done. Sine of a double angle. Do double angle formulas. Remember, it's like sine 2 theta. Well, if you don't remember the double angle formulas, maybe remember the sum formulas. Sine of theta plus theta. Oh yeah, okay, now I remember the little trick. Sine of the sum of two angles. Remember I have the sines on the outside. Maybe that might help. So sine of the first on the outside, sine of the second there. And then it went cosine of the second, and I kept the same sign that I had there. So that's your double angle formula. Well, that's your sum formula, which is now a double angle formula. I have two of the exact same things right there. 2 times sine theta cosine theta, right? So now you can rewrite 2x as 2 sine x cosine x. And look, sine x disappears. So this is just the limit as x goes to 0 of 2 times the cosine of x, which now this is 2 times the cosine of 0. And you're like, okay, what was the cosine of 0? You can look in your calculator if you need to, but that's going to be 1. It evaluates. So that's 2 times 1 equals 2. The trig functions ones using a calculator, you can probably make a conjecture where it's going towards. Not always, because we know those trig function values or the function graphs themselves are waves, ups and downs, right? So once you start introducing the arguments to be 2x, 3x, 5x, all divided by some other trig function, you're getting some very unique pictures, lots of oscillations that are happening. So that's a, you're getting closer and closer to where x is approaching. You don't necessarily know that it's honing in on a particular y value. It can be slightly jumping back and forth, and not necessarily a unique pattern. What else? All right, so these one-sided limits, you got to be a little bit careful with them. First off, look at the function itself before you actually start going and try to evaluate. You might say, well, I could put in 3 in there. 3 minus 3 on the top is 0. 2 minus 3 on the bottom is -1. 0 divided by -1, 0. Square root of 0 is 0. But are we actually putting in 3? Remember, putting in the actual number is just a trick to help sometimes, right? The idea of a limit is you're approaching 3, in this case from the right. So these are numbers like 3.1, 3.01, 3.001, something like that, right? Looking at the function itself, and as the radicand, that quotient, x minus 3 over 2 minus x, there's nothing I can simplify, right? Nothing factors, nothing cancels, nothing, it's as simplified as possible right there. You might be able to rationalize it. You could possibly say this is the square root of x minus 3 over the square root of 2 minus x and rationalize. You now have just the square root times another square root is the square root of the x minus 3 times the 2 minus x over a 2 minus x. Not plus, because I'm doing as one entire term. So I'm multiplying the top and bottom by that same term, not a conjugate.
Positive sign. The square root of x plus, or 2 plus x.
No, that's basically, if I was doing this, square root of 2 minus x,
Oh.
then I multiply by the conjugate. This is all under the radical, so it's just one square root. Yeah. No, good to catch that out because you see two terms, you would think conjugate. It's two terms under the radical, one radical. So top and bottom by that one radical. All right, so you get this right here. Now this part's under the radical, this part's outside the radical. This isn't really helping very much, right? Things on the outside can't cancel with things on the inside, so it's not helping. All right, so another thing is to always keep this in mind. You're approaching 3 from the right. So think about this, 3.01, I don't know, just pick a nice number, minus 3 over 2 minus 3.01. That's 0.01 on the top, right? And this will be 2 minus 3.01 is negative 1.01, right? Now, if you can pick smaller numbers or those that are closer to 3, but still in the right of 3 if you want. This is always what? No matter what numbers you're going to choose to the right of 3, always a negative quotient, right? And then so, can you take square root of a negative quotient? No. So this limit does not exist. And if you want to, you can look at the graph of that too. If you would type it all in, you'll see there are no x values to the right of 3. The function doesn't even show up. Now you can say, all right, what if it looked at 3 coming from the left? You're thinking about numbers like 2.99, right? But now you have 2.99 minus 3. It's negative 0.001, whatever it is, right? Still a negative number on the top. At the bottom, 2 minus 2.99 is 0.99, but negative. So it's negative over negative. Makes positive, right? So it would work. So you plug in some numbers in there. You could plug in 3. So 3 minus 3, and then 2 minus 3, 0 on the top, right? So that would be 1 towards 0 coming from the left. Graph works. So when you get some that are really tricky, just use calculator and pick some numbers, right? So sometimes the algebra gets, don't know where to go, try your calculator. All right. Let's go on to 2.4 now.